And this is produced for each virtualized application running in a virtual machine, whereas the performance index was at the host level. So this enables performance optimization and capacity planning at the guest level. And virtual machine performance index enables comparison baselining and continuous management of infrastructure performance for applications as they migrate from physical to virtual hosting. You can measure and baseline the infrastructure response time and the performance index for a physically hosted application, and then continue to report on these metrics as the application is virtualized, so you can make sure that you're still getting the best performance possible. As I mentioned, where performance index for the ESX server perspective that we talked about in the previous slide helps optimize the total VM load or density on the server, the VM performance index helps optimize performance and resource allocations of each virtualized application. Producing this VM level performance index requires a nested queuing model that accounts for all of the cross-domain resources in the system infrastructure, and then also evaluates the contention caused by all the competing VM applications sharing these resources. It's interpreted the same exact way as PI. So when the VM number is, the PI number is under 100, it tells you how much remaining capacity headroom a VM guest application has at a good performance service level. And when it's over 100, how much performance is degrading. So a good optimization example from one of our customers is Vistaprint. You may know them. They're a marketing services company providing printing and promotional products online. They have a large VMware environment with 700 virtual machines in 2 or 3 data centers running on EMC Clarion storage. They had an issue with their storage configuration. BalancePoint identified over time which applications on what volumes and at what times of the day were the I/O workhorses, so they could determine the appropriate mix of RAID types based on the application loads. The third value I'm going to talk about is capacity planning and how you use BalancePoint to do that. One of the ways we help users with capacity planning is through the virtual host resource contention feature. This produces a unique visual that represents a valuable averaging interval summary of actual host resource utilization by VM. The chart is pretty simple and simple to interpret. The bigger boxes show the biggest VM users of CPU and memory. It shows which VMs are using the most of the actual resources, or if there's a large chunk of allocated or unused resources going to waste. The chart is interactive, so you can click on it and get a quick examination of the resource entitlements and resource pools of the biggest VM hogs that may be candidates for possibly needing to have a new limit set, for example. Another way you would use this would be to check this chart if you were looking at a host server or virtual machine performance index over 100 to see which one might be the biggest users of or competitors for server resources. So a question here might be, how is this different from what vCenter shows me? And the answer is that vCenter only shows the host as a whole or utilizations by individual VMs. This view actually also can show who the heavy hitters are at a particular point in time and can help correlate those big CPU and memory users. Another way that you can use BalancePoint to plan your infrastructure is through the VMware ESX cluster level metrics. BalancePoint shows cluster utilization stacked by server to quickly show you the physical load balancing. It also shows it by resource pool, so you can analyze relative pool utilization. The server or pool gigahertz shown in the screenshot here is on the left, y-axis, and the total cluster capacity percentage is shown on the right. Total cluster capacity can be used to judge when new resources might be added, for example, or needed. And depending on resource pool definition, pool utilizations can show how departments, users, or other groupings are actually using the virtual environment. So as we talked about in the beginning of the presentation, capacity planning is hard in a virtual environment. And what we've tried to do with BalancePoint is create automated reports that make it simpler. But as we've also talked about throughout the presentation, you really want to be able to deliver the resources to the applications when they need it and without over-provisioning. And so BalancePoint's data center level statistics like infrastructure, response time, and performance index should provide the visibility and predictability for performance and capacity growth. We've also provided automated scorecards on virtual machines, servers, and storage, different views of those resources, so you can easily see a consistent set of metrics for all the different resources in your infrastructure. We also provide deep reporting on all the different storage arrays. For example, if you have NetApp in your infrastructure, we have a specific NetApp performance report that provides a summary view of the array, performance statistics for each aggregate and protocol, including the IOPS and throughput, and capacity and utilization for each volume and aggregate. With NetApp storage, latency or response time is a primary performance indicator. So, for example, one of the things that you'd be able to figure out with this report in BalancePoint is that CPU utilization is higher than recommended by NFS guidelines, for example. We have some best practices built into the product that kind of gives you a summary of that information. So you can go to the storage array CPU screen and then drill down on that problem specifically. So from a lot of perspectives, we view BalancePoint as an independent IT advisor. So you're not relying on your storage vendor to, make hardware investment decisions. Another customer example is AutoTrader. They've been using the product for several years now. If you're not familiar with them, they're the largest online auto classified marketplace. They run VMware infrastructure on NetApp NFS. They needed to figure out how many ESX servers to plan per VM cluster to support their company consolidation and growth plans. So what BalancePoint did was show them the information they needed, including server and storage usage, that enabled them to mix workloads to get higher VM densities without impacting performance. I think they went from maybe like 10 to 1 to 30 to 1 VM densities, and were able to, effectively manage their service levels. And this actually led them to virtualize more and accelerate their plans, which is great.